adults and the families. And for older students, virtual manipulatives feel more sophisticated than real objects.
Yes, I have heard that before. For some reason, secondary students seem to think that actually manipulating something in their hands is something only that the elementary school students do. And so this can be a nice transition for them. All right. So in addition to talking about what manipulators are actually out there, I really want to make sure that we also address today how you can use them in the classroom. There's a great quote out there by Jo Bullard, and she says, you know, although hands-on experiences really do can or have the potential rather to enhance perception and thinking, just putting the tools in students' hands does not make the understanding travel through their fingertips, right? So we still have to do quite a bit of work as educators to kind of frame the experience for them to make sure that they are getting the most out of it. And this isn't really a new idea. For years, the research has shown that it's not just using the manipulatives that causes that reasoning and sense making, it's how we use it. And so I want to give some ideas today as well on how you might use the different tools that we're going to look at. The 4 categories that I'm going to share are introducing concepts, how you might use virtual manipulatives to guide an exploration, how they can be used for scaffolded practice and feedback, and how you could use them to assess students' understanding. So let's dive in with the first one. The first website we're going to go to is GeoGebra. One of the things I love about this site is that there is a lot of content here. Not all of it is a lot of it is generated by users, and not all of it though is quality content. So there's a lot there and you kind of have to sift through. So I'm going to at least point you in the direction today of 3 that are really good. But just know that there's a wealth of them there and that you can't just click on one and, you know, go with the first one you click on. You might have to kind of dig through a little bit, but not all of the sites I'm showing today are like that. All right, so this is the GeoGebra website. Some of its main features are that it has multiple different calculators. So in the far right-hand corner, when I click on the 9 dots, there's about 6 or 7 calculators that are available for free, and they're actually all downloadable also as an app or on your computer. The resources on this site fall into 2 kind of categories. They either fall into books and activities, books or activities rather, books being a group of activities related to one concept, or an activity just being one standalone. This website does not require an account. However, if you do have an account, then there's a few extra perks, but nothing worth, you know, stressing over if you don't want to create an account. And then there's also quite a bit of video tutorials on YouTube from GeoGebra on how to use the site and how to create your own resources as well. So the first thing I want to point out here is that there's a news feed on the left-hand side where you can go and get quick access to some of their tutorials. And then the meat of it is all in this resources here. So up at the top, you can type in a math topic that you're going to be teaching, or down in underneath that search box, there's kind of like a web that's interactive. So if I click on, for instance, geometry, then the web changes dynamically, and there's other topics that are all related to geometry. And then they also, that as the web changes rather, the list at the bottom changes as well. So virtual manipulatives make great introductory tasks, mostly because they require interaction and you can generate interest in a topic very easily by just letting students have free exploration. And in fact, the research shows that students actually interact more when we are, went a little too fast there. That students interact more when the teacher gives minimal guidance. Now, this doesn't mean that you want to just let students have at it, right, with no directions at all, but you want to just keep it focused. So have a goal in mind already, a learning goal in mind, and then frame your questions around that. Even if you're going to use it as just an introductory task, you can still make some guidelines around that introduction. So one of the examples I have is you can have students just play with the sim for X amount of minutes and then share a question or wondering or something that they noticed. And the examples I'm going to show in just a minute have this whole range of no directions at all, or very minimal directions, or a full-on guided exploration. You can also tailor the task by having students answer specific questions that are going to point them towards the math that you want them to discover. So let's take a look at, and I think, Annette, you can put in the link in the chat box, the link for the functions one. That's the first one that we're going to look at here.
Great. Link is in the chat box.
All right. So, oops, let me zoom out a little bit. Okay, so if you can see on my screen, if you haven't navigated away, or if you've clicked on the link already, and you're looking on your screen, at the very top, you'll see this person, Jennifer Silverman, created a linear function tool. And she just has 3 very simple directions at the top to guide students. Don't move anything yet. Write down at least 5 things you notice about the graphs and equations and share with a partner. And then the direction is at one at a time, just move the sliders and write down what you notice. So I'm going to show, just in case some people are choosing not to, let me zoom out a little bit, choosing not to do it on their own. I'm going to just show you what happens when you move these sliders here. So this is an example of, I would say, probably somewhere in the middle between no directions at all and a few guided questions. And then underneath the tool, she also has one more direction to kind of lead students towards her learning goal, which is describe what each form of the linear function can tell you just by looking at it. All right, I'm going to point out 2 more tools, and then I'll give you some time to play with each one of them. The next one is the parallelogram. If you'll add that link in chat, Annette. This one is much more open-ended than the last one we just looked at. So it's just called Parallelogram Investigations, and the only instruction that's given is investigate the properties of parallelograms. So I would say this is on the very liberal side of directions. Students just have to play around with it to figure out that they can move points A, B, and C. D is static so that it can maintain the properties of a parallelogram. And then on the right-hand side, you could click some of the features of parallelograms, like the interior angles, and then they'll show up. So something like this would require a little more guidance from the teacher, but there's also perks to this because it's very open-ended and the teacher has control over what piece of the mathematics that they want to point out for the students. So with something like this, you might hope that students would recognize, like the opposite angles are equal no matter how they play around with it. And then there's also other ones that they can play with as well. All right, and then the next one I want to point out is the slope. If you'll add that link to chat. And again, I know I'm going fast, but don't worry, I'm going to give you a couple minutes to play with it more in depth. So this one, the teacher doesn't leave any directions at all, but there is, if you notice up at the top, this link for a worksheet in Google Docs, and it's much more guided than the other 2 examples we've looked at. There's step-by-step directions, but the directions don't tell the students what the math is. It just are directions on what do you notice, what do you wonder about these particular things. So for instance, they want the student to drag the white endpoints to make the different ramps that are shown below, and then tell which one is different. So students would use this sheet and then maybe go back to the interactive, drag the different points on the screen and see what happens. And I think for the first one, all of them are positive slopes except for the one example there at the bottom that they want students to discover. All right, so let's take about 3 or 4 minutes to explore any one of those 3 that I shared, or if you'd like to just go totally rogue and type in the search box of GeoGebra something that's coming up for you in your math class, feel free to do that as well. But explore the tools that I've shown here and think about how you might be able to use them to either introduce a concept or have students uncover a math idea or concept. All right, I'll give you about 60 more seconds, and then if you can come back to the chat and share, or even over audio, if you'd like to, you can share what piqued your interest, or if you found something that you think you could use, feel free to share that and how you might use it.
All right, so Angelina has shared with us that she really likes the slope tool, and she can use it in her concurrent lesson applying trigonometric ratios to have the students explore the relationship of the opposite sides and adjacent sides with respect to the angle of elevation.
Thank you for sharing that. And again, I just picked some of the virtual tools that lent themselves to what I was trying to highlight, but there's a lot of other slope ones out there that you might want to go back and explore as well that might have the check marks along the side, kind of like the parallelogram did, where they could see more features of the triangle.
And Samantha has commented that she loves the intuitive slope tool. She could use this next year with Algebra 1 students and for review next year, because this year's freshmen will definitely need the review.
Yes.
And Angelina commented earlier in the chat that also these virtual manipulatives in general are very helpful for ESL students, which she teaches.
Yeah, I want to hear more about that. What specific features do you think are helpful for the ELL students? Is it being able to see it? Is it the reactiveness?
Actually, this is Angelina.
Yeah.
Because I'm teaching ESL, so I see it because like I should try to like move each point, so the opposite side will like increase, and then the adjacent side will stay the same or decrease. Then they will see like, oh, the angle of elevation will increase or decrease, and if they have to move the other side, the other point, then they will also see the relationship, like how it connects to the angle of elevation. So it gives them more understanding about this angle of elevation instead of just having like a concept that, yeah, that's an angle, but so what? Now it will tell them like they can explore like, oh, so there's really a relationship within the two sides. And that's how I want them to see it using trigonometric ratios.
Yeah, and they can actually see it happening
Yes.
as it's as they're manipulating it. Yeah.
Yes.
That's definitely one of the advantages of using this over like a paper pencil task, right? Where they would have to draw and calculate each angle. Yeah. All right, let's move on to the next site. I'm really aiming to get to 3 of them today. So this next site is Desmos. Is anybody familiar with Desmos? Give me a yeah in the chat or?
Yes.
Okay. So Desmos has some of the same features as GeoGebra with the calculators. However, one of the things I love about Desmos is the ready-made classroom activities. So there's a lot less teacher prep if that's what you're looking for. You know, there's a lot of activities on there that are ready to go. And during this time of distance learning, they even have a whole special section just related for distance learning lessons. The other feature that I really like about this site is that there's a class gallery and a teacher dashboard. So the teacher can actually see in real time what the students are doing with each manipulative that they're using. So that makes great for when you go back to your classrooms and you're maybe trying to have a whole class discussion, or even if you want to take snapshots of what students are working on and provide feedback that way. In a remote environment, you could do that with a tool like Padlet, or even just take a screenshot of students' work and email it or put it in the Google Classroom, whatever platform you're using. Student accounts are preferred to get the most use out of this website, but it is not required. So you can definitely use it without having all of your students set up accounts, but I think you'll get the most bang for your buck if you have students set up accounts, and I'll show you what it looks like both ways. And just like GeoGebra, there are video tutorials on the website as well. So let's talk about another way that you might use virtual manipulatives that is really highlighted on this site, Desmos, and then we'll dive into playing around with a few on here. Unlike concrete manipulatives, we've talked about this, that virtual manipulatives are reactive. They talk back, right? Not literally, but they do. There's a lot of implicit scaffolds built into the virtual manipulatives on the Desmos site, where the learner receives feedback in order to frame their learning without it having to be do this next, without that explicit guidance. So in the Desmos I chose to highlight today, marble slides, the students are going to get feedback immediately from the virtual manipulative about the linear equation that they're trying to write. So let's try out the marble slide activity, and then we'll come back and discuss the different opportunities for the learner to get that feedback. So Annette's going to put in chat the link for marble slides. And, oh, you know what? Let me, before you, did you already put it in, Annette?
Yes.
Okay, that's fine. That's fine if she already put it in. While you navigate to the site, I'm going to just quickly go over what the site looks like without an account. So when you first get to Desmos, there without an account, it looks pretty bland. There's like a most popular Desmos along the side, and then you also have a search box up at the top where you can find them. And then that's pretty much it for without an account. Now watch what happens when I sign in. And you can sign in with Google. That's what I did. It made it super easy to create an account. Once you actually sign in and you get to the home page, there are resources for distance learning right there up at the top. So what I love is that they've already curated them by grade level based on the Common Core standards. So you can just click here for grade 6 and find all the ones that are relevant to you. Let's see, what else? The other feature on this site is that they have collections. So once you've created an account, you can find manipulatives that you like and group them together and then use those collections for one particular class or assign them to a class. Whereas with GeoGebra, you can just share the link up at the top in any format, whether that's in an email to students or on Google Classroom. In this site, though, you can create almost like your own class within the Desmos site. So let's look at my collections that I've created, and we'll look down here at the writing equations one. So here I've put two different virtual manipulatives that relate to writing equations. The one we're looking at, the one that Annette gave you the link to, is Marble Slides. Up at the top, it gives a brief description, and they're all set up this way. And then down at the bottom, these are the screens or the problems that students would explore and work through. There's also a teacher dashboard once you create a class. So I created a class for us today. What happens, what comes up, I can't like zoom out here. Hold on, let's see if we can zoom out so you can see it. Okay, so once I've created a class code, you have the feature then to either just share the link. This is what Annette just shared with you all that takes you directly to the site, to the Desmos that I created for this class, or you can give students like a class code. Once you get there, this is what the teacher sees on our end. I can see snapshots of every screen or problem students are working on with the virtual manipulative and get feedback on whether they got it correct or incorrect. Now, I made up Captain America and Minnie Mouse earlier this week. That's why I already have feedback on those two students, but there's also someone else who already is playing around with it, which is great. You can anonymize everybody in the room so that if you wanted to share this whole class and all the screens, you could. You can pause the lessons and pace it. So if I click pacing and I only want students to work on slides 4, 5, and 6, then I can limit them to those slides for today. And then the other feature I want to show is on this summary page. If I click on one of them in particular, I can see what students have worked on, and this will populate more in a moment once you all play. So Annette gave you the link. Again, I'm not going to give very many instructions because I want you to see how intuitive it is. Go ahead and go work through slides. Let's just do 1 through 4. Play with those slides, and I'm going to leave this teacher slide up so that you can see also, if you want to toggle back, what happens on the teacher end. So I'll give you 3 to 4 minutes to play with this one. Go ahead and get a few things wrong also so that we'll have some good data to look at. All right, so if you can pull yourself away from this one, I know it's kind of addictive, and come back to my screen, I want to show you what pops up on the teacher dashboard, which makes this a great tool for giving feedback and scaffolding learning. So watch what happens. So here, I can click on slide 2, the very first one that you worked on. And I'm going to anonymize it so that we're not putting anybody on the spot. But I can pull up this person's Emily J. I don't speak French, so I'm not even going to try. But I can pick this person and click the launch button, and we can all talk about what this person did to make this marble slide work. Or I can go to another one. Let's see. Did anyone get them wrong? If I go to the summary here. Okay, so if I go to the summary, I can select this one, and we can see, uh-oh, what happened here? The person didn't put in an equation at all, and so that's what happened. But the class could have a discussion about this and maybe give feedback to this particular student. And again, they don't have to be on the spot because you can hit the anonymize button. All right, so let's share in chat. What are some things that you like about this site? What are some of the benefits of receiving immediate feedback? How did you get immediate feedback when you were playing with this one? I'd love to hear your thoughts either over the audio or in the chat box.
Feel free to unmute your microphone and speak if you want to share anything about this, or you can type in the chat box as well.
No pressure. We're all family in our first 45 minutes together.
And some of you mentioned you have to hop off for another meeting. I think the EL Haynes crew has to hop off in a couple minutes.
That's fine.
So
I am recording it.
follow up.
So
Yep.
I'm recording it. So I can share the link to the recording if you want to catch the last website. I am going to try and squeeze it in there before 11:30. So anyone else want to speak? Share? Did you like it? You didn't like it?
Someone said they loved it.
Okay. What did you love about it? Which piece in particular? Were you able to see how the feedback, how you get immediate feedback?
Sarah has shared that she loves it and it helps students discover things on their own and explore. And Kendra has shared that she likes that through this activity, students can get immediate feedback on their equations.
Mm-hmm. And again, there still has to be some teacher input, right? We can't just let them go off and play with this and be like, yep, they got linear equations now, but we'll have to have conversations that are meaningful about, you know, what did you notice happened when you changed this part of the equation? And that pause feature helps a lot. Go ahead.
And Samantha has shared that it's very helpful and that she already uses these resources, but want to give kids more autonomy. And this is a tool that can do that.
Okay.
Camille has commented about loving the immediate feedback, and it has great transformation activities. And Samantha has shared that she's used other resources on this site. And Sarah has shared it supports students to create their own understandings.
Yes, and I want to show one more feature for those of you that are new to it. So the other highlight here is that this one, I know we have an ESL teacher in the room. So this one is, a lot of them are translated into multiple languages. And if you click in the right corner of your virtual manipulative, it says teacher guide, and it's got some great questions to help you plan and opportunities, thinking about like where might you want to stop and pause and discuss different slides, and what kind of questions you might want to ask. So that was just one last feature there. All right, so let's dive into the next one. The Phet simulations. This website might be my favorite. Maybe that's why I saved it for last. I'm not quite sure. It's a strong tie between this one and another website that I like that will get its own webinar all on its own. But this one I like because of the real world context. So there are a lot of simulations on here that help students make connections to the real world and how to apply the mathematics beyond our four walls of the classroom. So this website also has teacher guides like Desmos, but they are mostly user generated. Again, they come in multiple languages. There is not a student account required. In fact, there's not a teacher account required either. And then there are also many cross-curricular manipulatives with this site as well. So they have science and math as well. So I want to feature on this website how you can use virtual manipulatives to assess students' understanding and how also to press for their reasoning. Like, why does this work, right? These simulations are great for that. So the one we're going to look at today is about rates, ratios and rates. So this one in particular is going to help students define what unit rate is and the strategies for calculating their unit rate. So you can ask questions with a tool like this, such as use the tool to explain how you found the unit rate, and then kind of assess students' understanding from their answers and what they do with the tool. So Annette's going to put the link to this one in chat. I keep doing that. I keep jumping ahead. So let me go to the website. So when you go to the Phet website, right up at the top, there's simulations and they're already categorized. If we click right on the ones for math, you get a list right there. You can also sort by grade. They have a wonderful tab about different ways to teach with them and what are the best ways. So this particular website does a lot of research on virtual manipulatives and how to use them effectively. So they give a lot of tips and tools that might be coming in a webinar to you very soon on how you can get the most bang for your buck with this manipulative. Like, what questions do you want to ask? So the one we're going to look at is the unit rate. And I think Annette probably put the link in chat, which is great. Right when you get to the website, the link Annette gave you is the one I would give to students, which takes them directly there to the virtual manipulatives. The link that I'm on right now is from the main website. And right away, you can see that you can download it. So this is one where students can use it offline. They have a link for teachers where you can open the teacher tips. I think you can only access this though when you are logged in and have a teacher account. So the teacher tips offer for you how to use the manipulative as well as some ideas for how to create a task for students and things that students usually get tripped up on. So that's helpful too. All right, to click on from this teacher website, you can click right on the picture of the manipulative and it opens it up, which is where you are exactly right now if you use the link Annette gave you. The other thing I like about this website is that they're differentiated. So there's usually more than one manipulative for that concept. This one has 3 different ones. There's a shopping manipulative that focuses on students actually finding and calculating unit rate. The shopping lab focuses on students being able to create the rate themselves. And then the racing lab allows students to compare 2 rates. So it's kind of scaffolded in the concept. So let's take a look. We're all going to look at the shopping. And I need to minimize my screen. So go ahead and play with it for a few minutes and then we'll come back and talk about it. All right, so a few features that you noticed. Can anyone share out, like, what did you discover? What can you do with this manipulative?
So Kendra has shared you could set your values with this.
Yes, with the shopping cart one, you maybe went to Shopping Lab. This one, the rate is already set for the fruits and the vegetables, but yes, you do have that option under Shopping Lab. I think the only thing, so you can do fruits, vegetables, and this last one here is candy, and it progressively gets a little harder for each one. So with the apples, you can actually find the unit rate just by, you know, getting one apple on the scale. But when you get to the candy, by this point, students should have some other strategies for how to figure out the unit rate, because you can't take the candies out individually. Did anyone notice the double number line up at the top and how that works? What did you notice about that? So the double number line up at the top matches whatever's going on down on the scale. And so, for instance, when I put one bag of carrots on the scale, and I think it has 3, I can't see that good, but it has 3 carrots in there. So one bag is 60 cents. So the double number line there matches what's happening on the scale, which students could use to help figure out the unit rate if they are, let's say, trying to find like the midpoint between 2 of the points on the double number line. Or maybe they're calculating the integer multiple to figure out the rate. So there's a lot that you can do with this one. And again, it gets more difficult as you run through each of the simulations, all dealing with rate. The other thing I want to point out is that over here on the right-hand side, it also has questions that automatically generate. There's like 4 different questions that cycle through. Depending on, like, it's randomized, so all your students can get the same questions every time. All right, thoughts about this tool? Any additional benefits or different ideas about how to use it that you'd like to share? All right, well, Annette's going to share in the chat box now a document that I created to kind of help you find virtual manipulatives. So I've highlighted the 3 sites that we talked about today on this document, but then I've also included 2 more websites at the bottom that we didn't look at that will probably be featured on another Friday. I've also given some points of interest. I tried to pick some high profile topics down at the bottom and suggest you and point some in your direction, but those are not, you don't have to use those ones. There's a lot out there, but just if you're looking for a starting point or a jumping board, that would be a good place to start. All right, we have a few minutes left before our session's over, so I'd like to just open it up for discussion. Feel free to use your audio at this point. And don't forget our norms for virtual engagement. So if you're not speaking, keep yourself on mute, and I encourage you to participate. There will be guided questions on the slide, but don't feel like you have to stick to those. We can talk about anything that you like. This is what the space is for. Anything related to teaching math remotely and maybe the challenges or the successes that you're having. If one of the questions on the screen resonates with you, feel free to answer it, but if not, and there's something else you want to bring up or a question you have, I welcome that as well.
And Tanaga, several people had to jump off for another meeting.
Okay.
So we have a smaller group, but still have some folks on the line.
All right, well, chime in. Brain is on slow-mo. Still coming up with reasons you love Desmos. That's totally fine.
I'm going to talk now quick. Hi, this is Camille. How you doing, guys?
Hi, Camille. And hi, little friend.
I know. I'm sorry. That's why I was on mute the whole time. But yes, we actually have the day off for
That's
teacher
fine.
appreciation. And I definitely have been using a tool that I love called, well, it's just a calculator, actually. I didn't know that GeoGebra has the graphic and scientific calculators available, so I have to check that out. But Wabbit.
Oh, Wabbit. Okay.
Yeah, emulator has been super helpful for my students.
How do you spell that? Is it W, maybe?
Yeah, it's WABBIT.
Okay.
And it just generates like literally a TI 80, whatever they download, 82, 83, 84 plus.
Okay.
So since a lot of my students don't have access to that at home, it's been helpful to kind of download that and walking them through how we're transforming different functions. And we can type in different forms of the equation, in the graphing calculator has been helpful. Desmos I also love because you can it's individual pacing. So some students work a little slower and they're early in their assignment. You can kind of shoot over to them and give them individual help. Whereas some of the students who work a little quicker can kind of go on to more challenging problems. So I appreciate that aspect. And also just being able to capture and present student work immediately so the whole class can kind of pause and analyze it is super helpful.
Yes.
I'm going to look more into, I think you call it Phet, Phet.
Yes, you got it.
And learn a little bit more about that. But thanks for sharing overall.
No, thank you. Thanks for participating. Is there anything, Camille, that you'd like to see in an upcoming session? Anything in particular?
Right now, I'm just going to explore what you've shared. I mean, this is really what I've been wanting and needing, because I mostly use I use a lot of Khan Academy, and I use a lot of like IXL and a lot of just trying to share kind of flat, kind of two-dimensional teacher resources that I would have made more engaging in the classroom. But now that we are kind of virtual, they don't have the same effect. So this has been good. And I mean, Khan Academy and Desmos and all these virtual tools, they can teach some things to me a little bit easier. Like when it comes to things like transformations or things that are angle related, seeing it with those tools and being able to toggle is like life changing for the students. It would take us like hours to accomplish the same thing with a piece of graph paper and a coordinate plane that they can accomplish in minutes.
Yeah. Thank you for sharing that, Camille. That's very insightful.
No, thank you.
All right. Well, it is just about 11:30. I will be more than happy to hang around, and if other people have other questions or comments, I'll be more than happy to stay and discuss those with you. But I also want to respect others that need to hop off right now. Just a few closing items. In addition to these weekly content sessions, there's also a resource guide that's available on the OSSI website, and I'm also available for individualized support. So if you really liked what you saw today and, I want to use this, but I need a little more support or have some more questions, feel free to reach out to me. Annette's going to put my email address in the chat. And if you want to sit down for 20 or 30 minutes virtually, we can talk about your next lesson that's coming up. And then the very last thing is Annette's going to put a link in chat for a Google Forms survey. If you'd like to give some feedback on today's session, I would really appreciate it. And other than that, have a great Friday and enjoy your weekend. I don't know, is this like week 8, 9, 10 of social distancing at this point? I've totally lost track, but enjoy it. I hear the weather is supposed to be nice, except for tomorrow morning.
And Tanaga, the link to the survey is not pulling up for some reason in the browser. So I'll just, and some people have had to step out. So I'll just told everyone that you would email them the survey link as a follow-up.
Sounds good. Sounds perfect. All right. Thanks, everybody. Have a great weekend. And I'll hang around for an extra 5 minutes if anybody still wants to chat. Thank you so much, Annette, for moderating for me.
Oh, it was easy. You made it very easy.
You're very talented.
Everyone is giving major props in the chat box.
Oh, that's awesome. I'll have to go back and read it.
Thank yous. I love it. All that stuff.
Love it.
Now, do you have a list? Are you able to access a list of who attended today? I took a screenshot of the participant list when everyone was there, just in case. But I don't know. Yeah. Oh, shoot. I got to go to my next meeting with
You're good.
Siobhan. All right.
Bye.